In this video, we want to find the multiplicative inverse of this matrix with components 1, 3, and 5, 10. There's several ways you can do this. I'm going to look at one method that's a little bit longer that uses row operations, and then we'll look at a shortcut. And this method applies to, in this case, a 2 by 2, 2 rows, 2 columns. So just like with numbers, say you have the number 2, the multiplicative inverse of 2 is 2 to the negative 1, or 1/2, because 2 times 1/2 gives you the identity element for multiplication, which is 1. 1 times any number gives you back the number. Same sort of thing with matrices. The first method uses an augmented matrix. I'm going to make this a bar here, or this, and then to the right of this I'm going to put the 2 by 2 identity, which looks like this. I'm going to close this. So that the identity element or matrix is simply one who has ones along the main diagonal here, from the left down to the right here. The 3 by 3 identity looks like this. They're all square. It has 1 along the main diagonal, that would be right here, and everything else is a 0. You can have a 4 by 4, 5 by 5, and so on. They'll have to be square matrices. For the number of rows is the same as the number of columns. So here's the objective in this procedure. This is your 2 by 2 identity right here. We want this matrix to appear on the left side. Then whatever appears on the right side will be the inverse. So let's suppose that we have the matrix given as A. We're looking for the inverse. We're going to call that A to the negative 1, but that's not considered like an exponent. You read that A inverse. So we want the matrix on the left of this bar to have components 1, 0, 0, 1. Well, we have a 1 right there. So we want this to be a 0. We want this to be a 0. And we need this to be a 1. So I'm going to use row operations. So I'm going to use the first row, multiply it by a negative 5, and add it to the second. These are row operations. Same sort of thing you do when you solve a system of equations, of linear equations, to eliminate the x or the y. So multiplying the first row by negative 5, and then adding to the second, that's legal. So negative 5 times 1 is negative 5 added to 5 is 0. Negative 5 times 3 is negative 15 added to 10 is negative 5. The negative 5 times 1 is negative 5, added to 0 is still negative 5. So all we're doing is multiplying the first row by a negative 5 and adding those products to the second row, corresponding elements. The negative 5 times 0 is 0, added to 1 is still 1. So I have that. Now the next thing I want is this number right here, in this position, to be a 1. I already have the 1 and 0. Remember, I need 1, 0, and then 0, 1. So I have 1, 0. I want this negative 5 right here to be a 1. So let's just divide the second row, everything in the second row, by negative 5. Well, 0 divided by negative 5 is still 0. Negative 5 divided by negative 5 is 1. Same thing here. Negative 5 divided by negative 5 is 1. And 1 divided by negative 5 is negative 1/5. So we got a 1, 3. This is 1, 0. And now I'm dividing the second row by negative 5. So this is going to stay a 0. Negative 5 divided by negative 5 is 1. Again, negative 5 divided by negative 5 is 1. And 1 divided by negative 5 is a negative 1/5. So I'm 3/4 of the way there. I got a 1 here, a 0 here, and a 1 there. So now I write the second row the way it is. So I want this 3 to be a 0. So notice I can multiply the second row by negative 3 and add to the first row. So negative 3 times 0 is 0. Added to 1 is still going to be 1. And that's good because I don't want that to change. Otherwise it's messed up. Okay, with the same components, 1, 0, 0, 1. Okay, then multiplying them by negative 3 here. Second row by negative 3. So now I did the first component. Now negative 3 times 1 is negative 3. Added to 3 gives me 0. Negative 3 times 1 is negative 3. Okay, over here, negative 3 times 1 is negative 3. Added to 1 is a negative 2. And then negative 3 times a negative 1/5 is 3/5. Added to 0 is positive 3/5. Now we're pretty much finished here. So here's the situation. Again, if you want to find the multiplicative inverse of a matrix, in this case, it's a 2 by 2. We put it right here. This is called an augmented matrix. And then on the right side, you put the corresponding identity matrix. If you're working with a 2 by 2, this will be the 2 by 2 identity. 1, 1, and then 0, everything else is 0. If it's the 3 by 3 matrix you're finding the inverse of, then this should be the 3 by 3 identical. It'll be a 3 by 3 with 1s along the main diagonal. Everything else will be a 0. So if you do this, don't make any mistakes with the arithmetic, then whatever appears, once you have the identity matrix corresponding to the 2 by 2 in this case, on the left side, Whatever's on the right side will be the inverse. So what do we have? We have a -2, we have a 3/5, we have a 1 here, and a -1/5. This is your inverse. And again, just make sure you can read the writing here. The first component here, the first row is a -2. There's a -2. For the second component at that first row, that's 3/5 right there. And then we have a second row, we have a 1 and a -1/5. Now one way you can check is multiply two inverses. So A inverse for the matrix and its inverse, I should say. So if you multiply the matrix and its inverse, this will come out. This should come out to the 2 by 2 identity. This should be a 1 0 0 1. So let's do it here. Let's use the first row. So in this case, what we do is the rows multiply into the column. So again, this will be, if we do it this way, be a -2 times a 1 is -2. 3/5 times 5 is 3. So -2 and 3 gives me 1. There it is. Checks out. And then you do it with the next column. So -2 times 3 is -6. And 3/5 times 10 will give me 5 into 10, 2, 3, 6. So it's -6 and 6. And this will give me a 0. Checks right there. Now you do the second row with those two columns. So 1 times 1 is 1. -1/5 times 5 is -1. 1 and -1 is 0. Right there it checks. And then the next one, 1 times 3 is 3. And then -1/5 times 10 is 2. 1 and 3 and -2 is 1. So 1 times 3 is 3. -1/5 times 10 is -2. 3 and -2 is 1. That's your check. But that's the way you do it this way. Now let me show you another way. This is a shortcut of this method here. So for this one, let's call this matrix A again. And we need, and we'll call this A. And for this method, we need the determinant of A. Very easy to find the determinant for a 2 by 2, because all you're going to do is cross multiply this way. So it's 1 times 10 is 10, and then this way 3 times 5 is 15, and then you subtract that. 10 minus 15, this is -5. That's the determinant. Cross multiply and subtract those products. The first part of this procedure. And then the next thing we do is find the cofactor matrix. Cofactor matrix. With a 3 by 3 is a little bit more involved, but with the 2 by 2, all it is this. Just interchange these two values. So the 10 comes over here, the 1 goes over here. And then interchange these two values, except change the sign. So the 3 goes over here, but it goes to a -3. 5 goes over here, interchange, and that gives me a -5. Okay? So again, for the 2 by 2, find the determinant, then switch these two. 10 there, the 1 goes over here. And on this diagonal over here, same thing, replace those, but change the sign. So the 3 comes over here, change the sign, 5 goes over here, change the sign. And then the next thing we do is what's called the transpose matrix. So the rows become columns. So this 10, -5, and the columns become rows, if you want to say it the other way. So it's going to be a 10 here, and a -5 here, and then a -3 here, and a 1 here. So the inverse, then, is given by the determinant of A times this matrix here. This is sometimes called the adjoint matrix. The adjoint matrix. So that's multiplied by the determinant. 1 over the determinant, I should say. So this was actually 1 over -5. Or another way to say it is you divide each component by the determinant. Okay. Multiply this matrix by 1 over the determinant of the matrix, or it's the same thing as saying divide each component of the matrix by -5. So this will give you, so this -5 into 10, that's a -2. Then -1/5 times the -3 is 3/5. 1 over -5 times the -5 is going to give me a 1 here. And then -1/5 times 1 is -1/5. And that's the same thing we got using the other method. Took a little bit longer. But in essence, what we're doing is finding the adjoint matrix, which is this right here, and then dividing the components or multiplying by 1 over the determinant of this matrix. So the determinant was just cross multiplying and subtracting. We got this. So again, what did we do? We interchanged these two components. The 10 went over here, the 1 went over here. The same thing here. go in the other diagonal, interchange. 5 goes over here, the 3 goes over here, but it changes, you change the sign. That's called the cofactor matrix, if you want to give it a name. This is the cofactor matrix. We looked at finding the value of a determinant using cofactors and minors. That's what this is. But the short way to find the determinant is just cross multiply, like I said, and subtract. So again, we get the same matrix here. Components here, in case you can read them, -2, 3/5, 1, -1/5, which is the same answer we got using the longer way. Thanks for watching. We'll see you next time.